Okay, so now let's talk about this nice looking exponential equation we have here. We have 5 raised to the power x plus 1 plus 5 raised to the power 2 minus x equals to 5 cubed plus 1. What we are going to do, we will gonna solve it for x. So let's get started. Okay, so we have 5 raised to the power x plus 1. We know that we can break it down in 5 raised to the power x and 5 raised to the power 1. Okay, this dot is multiplication indicating we are multiplying it by 5 raised to the power 1, and by reversing this step we will gonna have what we had previously. We had 5 raised to the power x plus 1. So move forward, we have 5 raised to the power 2 minus x, so we can write it as 5 raised to the power 2 and divided by 5 raised to the power x. Because we have this minus sign, so this 5 will be will go in the denominator, and here we have 5 cubed. Should I change it or not? Let's see. Yeah, I think I have to change it in 125. 5 cubed is equals to 125 plus 1. Okay, in the next step I will do it as 126. So now as you can see that in this step we have 5 raised to the power x here and 5 raised to the power x over here. So what I'm gonna do, I'm gonna let 5 raised to the power x is equals to some other variable. Let's call it y. Yeah, so we have y into 5 power 1, so we can write 5y plus 5 squared, so it will be 25, divided by y is equals to 125 plus 1, this is 126. Now let's make some space here. Now we will firstly find the values of y and then we will plug it into this equation. Let's call it equation number 1. So we will have our solutions for x then. So now we will by taking LCM, we have y and it will become 5y square plus 25 is equals to 126, and by cross multiplication 5y square plus 25 is equals to 126y. Let's bring 126y to the left hand side, so 5y square and this 126y will become minus 126y plus 25 is equals to 0, and voila, it became quadratic equation. Now we will just need to use the quadratic formula, or if you may use factorization, it's totally up to you. I'm gonna use quadratic equations to solve this, or nah, I think I can go through factorization quite easily. As you can see here, 5 times 25, it will be 125 y square, and the middle term is 1 minus negative 126 y. So we will just have to think about some values whose product will be 125 y, and by performing sum here we will get minus of 126 y. So yeah, we have 125 y minus y minus times y times minus y, and minus 125 y minus y. Okay, so we will get 125 y square over here and 126 y of negative. Okay, so in the middle term we will use 5y square negative of 125 y and negative of y plus 25 is equals to 0. You can use the quadratic formula over here too. It will be up to you which method you prefer. So now we will just have to take common or factorize it. So over here we can factor out 5y and we will get y negative of 25, and we can get negative of 1 as a common here, and y minus 25 is equals to 0. By taking further factors, we will have y minus 25 and 5y minus 1 is equals to 0. Let's make some more space, and we can equate it as y minus 25 is equals to 0, or 5y. So it will have 5y minus 1 is equals to 0. I do this thing quite frequently. So we have y minus 25, so y will be 25, and from here y will be equals to 1 over 5. So we have two values for y from here, and we will plug this value into the equation number 1, which was, so let's write here, put y in equation 1, which was 5x, 5 raised to the power x is equals to y. And yeah, firstly we will put 25, so 5 raised to the power x is equals to 25. Now we will have to make the bases equal. So here we have 5 raised to the power x. We can't further extract another base over here, but in the right hand side we have 25, so we can make it 5 raised to the power 2. So we will do that, 5 raised to the power x, and it will be equals to 5 raised to the power 2. Now the bases are equal, which can lead us that x is equals to 2. And from here we have 5 raised to the power x is equals to 1 over 5, and this 1 over 5 we can shift it in the numerator, so we will have 5 raised to the power negative of 1, and here we have 5 raised to the power x. Now the bases are equal, so x will be equals to negative of 1, and yeah, we have our solution set for x. X is equals to 2 and x is equals to minus 1. But let's wait. How can we be so certain that these are the solutions? So what we will do, we will put these values in our equation or the question we previously had, and check that does it satisfy our equation or not. So we had 5 raised to the power x plus 1 plus 5 raised to the power 2 minus x is equals to 5 cube plus 1, which was just 126. So I will write 126 over here. Now for 2 we have 5 raised to the power 2 plus 1 plus 5 raised to the power 2 minus 2 is equals to 126. Here 2 plus 1 will be 3, and 5 raised to the power 3 will be 125, plus 2 minus 2, these two will cancel out, so 5 raised to the power 0, and any number raised to the power 0 is just 1. So yeah, we have 125 plus 1 is equals to 126. So it is satisfying the solution. So now we will insert minus 1. So we will have 5 minus 1 plus 1 plus 5, 2 minus x, so it will be minus times minus 1 is equals to 126. This should lead us towards 126. Let's see, minus 1 and plus 1 will be cancelled out, so 5 raised to the power 0 it will be 1, plus 2 and minus minus it will be plus, so it will be 2 plus 1 it will be 3, and 5 raised to the power 3, yes, it is 125. So 1 plus 125, it is also leading us towards 126. So it is also satisfying our solution. So it was a quite neat problem that we have solved. So if you like the video, give it a thumbs up, and I'll see you next time.